Okay, just a second while I fix this. It's kind of frozen. I didn't realize it until I pressed play. Okay, today we're going to talk about geometric sequences again, but we are going to specifically talk about the ways to write the formulas in geometric sequences. So, read your notebook on page 50 and 51. You're going to label 50 and 51, 15.2, constructing geometric sequences. And then you're going to take the foldable that you either have or you're writing on page 50. (15.2) constructing geometric sequences. Okay, so I'm going to put my notebook to the side to get the foldable out. So here's this foldable. First, we're going to start with what is a geometric sequence. Yes, we did this yesterday, but that's okay. Nothing hurts to refresh a little bit. A geometric sequence is a sequence of numbers where each term after the first is found by multiplying the previous term. So for this example here, to get from 3 to 6, we multiply by 2. To get from 6 to 12, we multiply by 2. To get from 12 to 24, we multiply by 2. All right, let's talk about the common ratio. To find the common ratio, we divide the second term by the first term. So we're actually going to do that on this one. The second term is negative 10. Remember, we use R. Negative 10 divided by the first term, which is 5. So the ratio is negative 10 divided by 5, which is negative 2. A geometric sequence is the only type of sequence we'll learn about where you can have positive, negative, positive, negative. Okay? All right, now let's talk about how to write the rule. The explicit rule. Remember, that means you can plug it in directly. The explicit rule for the nth term of a geometric sequence with a common ratio R is A sub n equals A sub 1. We've heard that before. That's the first term. Times R, the ratio. Now, I want you to put parentheses around R because it will help. It will look neater. It's easier to understand. It's still just multiplying, but we're going to use parentheses. All right, that means we need to find A1 and R before we can write our equation. A1 is the first term. The first term is 2. R is the ratio. The ratio is the second term, 6, divided by the first term, 2. The ratio is 3. Plug that in. Plug in 3 and 2. We write down A sub n equals, instead of A sub 1, we put 2, open parentheses, we put R, which is 3, close them, and then n minus 1 is an exponent. It's not over here to the side. Make sure you make it as an exponent, because that's what it is. Okay, now we're going to use it. How to find the sixth term. To find the sixth term of a sequence, substitute your value of n into the explicit formula. So if we want to find the sixth term, A of 6, we are going to plug in a 6. And we're going to plug that in just like it says. I don't have my calculator open and should have, so I'm going to open it now. Sorry. See, I should be prepared and open it before I start the video, and then I don't. And it takes a minute to open. In front. Alright, here we go. Now we're going to type this in, so I'm going to clear everything out. We're going to type in 3 parentheses 2. Right here under clear gets us so we can type in 6 minus 1. And that gives us 96. So the sixth term, A sub 6 equals 96. That's the answer. That's the sixth term. There we go. You can actually see it. You cannot. There you go. All right. Next, we're going to talk about how to write the recursive rule. So I'm going to close all these because they're getting in the way. To write the recursive rule. The recursive rule for the nth term of a geometric sequence with a common ratio r is written as a sub 1 equals a sub 1. Remember last time when we've done this before, we did it with arithmetic sequences. Instead of the comma, we would just skip a line. And then a sub n equals r, the ratio, times a sub n minus 1, meaning the one before it. So we're going to write that. First, our first term is 4. Our ratio is the second term 8 divided by the first term 4. So 8 divided by 4 is 2. So our common ratio is 2. Okay? Then we're going to plug it in. We're going to write a sub 1 equals 4 and a sub n equals 2 times a sub n minus 1. Remember that sub means it's below. It's written slightly below. That is the recursive rule. Now back when we did arithmetic sequences, we were able to simplify the explicit. We cannot simplify any of these, so we just write them and move on. All right, last, how to find the first 3 terms using a recursive formula. To find the first 4 terms, it says first 4 inside, so we're going to do that, of the sequence, start with your first term, then use the formula to find the next 3 terms. So we're going to make a table. We're going to do 1, 2, 3, 4, a sub n. The first term is 3. To find the one after 3, it says we multiply by 2. So 3 times 2 is 6. 6 times 2 is 12. 12 times 2 is 24. There are our first 4 terms. Okay, we're going to keep going. We're going to keep writing these. I want you to glue this in on page 50. And then we're going to write on 51. Okay, 51. I'm writing the instructions in different colors so you understand exactly which piece we are answering during the lesson. So first, we are going to write a recursive rule. And my glue is over there. I need it. And explicit rule for each geometric sequence. Thank you, though. Okay, then find the 7th term. So we're going to do those things first. So we're going to write a recursive rule and explicit rule, then we will find the 7th term. Number 1, our geometric sequence is 7, 2, 6, 18, 54, 162. Now, before we do either of these, no matter what, we have to find the first term, we'll highlight that in green, and the ratio. So the first term is 2. The ratio is the second term, 6, divided by the first 2, which is 3. So we will use that. Now, you need to have your foldable open that we just worked on so that you can answer these questions. So the recursive rule we're going to do first, and I'm going to put a big capital R for recursive. We've done that in the past. So I've got that open. It's over here on my foldable, and it says to start that, we do A sub 1 equals, the first term is 2, and then we skip a line and put A sub n equals the ratio times A sub n minus 1. That is the first part that says write a recursive rule. Let's write the explicit rule. Okay, I've got that one open. That one says we write A sub n equals the first term times the ratio raised to n minus 1. That's the recursive rule and the explicit rule. Now we need to find the 7th term. When we are finding the 7th term, we are going to plug in a 7 for the explicit rule. So A of 7 sub 7 equals 2 times 3 to the 7 minus 1 power. And we're going to type that in our calculator, and we will have found all the pieces. So my calculator here, 2 parentheses 3 to the 7 minus 1. 1,458. So A sub 7 equals 1,458. I was asked to do 1, 2, 3 things, and I've done 1, 2, 3 things. You need to make sure you have all of those done. Number 2. Number 2 is 10, 3, 0.9, 0.27, 0.081. The first term is 10. The ratio is 3 divided by 10, which is 0.3. Using my foldable, the recursive rule is A sub 1 equals 10, A sub n equals 0.3 times A sub n minus 1. There's the recursive rule. The explicit rule is A sub n equals the first term times 0.3 to the n minus 1. And last, we'll find the 7th term. A sub 7 equals 10 times 0.3 raised to the 7 minus 1 power. We're going to type that in the calculator. 10 times 0.3 raised to 7 minus 1. Okay, and I'm going to write it down just like it says. A sub 7 equals 0.00729. 3 pieces, I've done them all. Number 3, I want you to pause the video and do number 3. 5, 20, 80, 320, 1,280. So pause the video. Okay, the first thing you should have done is found the first term in the ratio. R is 20 divided by 5, which is 4. the ratio, not ratio, the recursive rule is a sub 1 equals 5, and then a sub n equals 4 times a sub n minus 1. The explicit rule, a sub n equals the first term times the ratio to the n minus 1 power. And then last, you should have plugged in a 7. A sub 7 equals 5 times 4 to the 7 minus 1. So A of 7 or sub 7 equals 5 times 4 to the 7 minus 1. 20,480. All right, I hope you were just checking your answer on that one. You need to pause the video and do number 4 on your own as well. 6, negative 3, 1.5, negative 0.75, 0.375. Okay, since you have already worked this and you're just checking your answer, first term is 6. The ratio is negative 3 divided by 6, which is negative 0.5. The recursive rule. A sub 1 equals negative 3. A sub n equals negative 0.5 times a sub n minus 1. The explicit rule. A sub n equals 6. Oh, I messed up. I don't know if you guys noticed it or not. I'll go back and fix it. Times negative 0.5 to the n minus 1. I accidentally put negative 3 instead of 6 here, which is wrong. And last, plug in a 7. A sub 7 equals 6 times negative 0.5 to the 7 minus 1. Let's hold that in place. 6 times negative 0.5, we could put 0.5, to the 7 minus 1. That is A sub 7 equals 0.09375. This is what you're doing on your assignment today. Make sure you pay attention to the directions. It might just tell you to write recursive and explicit, but if it tells you more, you have to do more. I'll see you later.